So, welcome to the essentially this should be part two series. This is part two of the series of the Heart of Algebra SAT Math component. Today we're going to look at um, inequalities, equations, and solution of equations with one variable. So, just to give you a brief summary of what is to come for this component of the SAT Math, the Heart of Algebra, according to College Board and College Readiness, involves a couple of things, mainly create, solve, or interpret a linear expression equation in one variable, create, solve, or interpret linear equalities in one variable, build a linear function that models a linear relationship between two quantities. So you can go to the site yourself, just type in College Board, Heart of Algebra, and you should find all the components that are involved in this series. So, and I'll give you some links for Khan Academy if you wish, but uh, let's get right into it. So let's start off with what we're going to talk about today, which involves equations. Right? We're going to talk about equations. Yeah. So in equations, what is an equation, right? Well, an equation is basically a statement that uses an equal sign. To put it plainly, it states a relationship between two quantities using that equal sign. So the general format of an equation, let's say, would be ax plus b, or common b, is equal to 0. Now what does that mean? That means that a, let me take this line off here, a by a certain component of certain variable x plus a number b is equal to 0, right? Where x is the only variable, x is the variable that we're interested in, right? We always try to find x. So in trying to find x, let's use a real life situation problem. Well, not a real life situation, but a more typical problem. So we're replacing a and b with numbers as they represent numbers, and x is our variable that we're trying to find. 3x plus 5 is equal to 8. Okay, 3x plus 5 is equal to 8. So here we may be asked to find the component x once again, right? We have to find x once again. Okay, well, intuitively we can say that, okay, well, x has to be 1, right? 3 by 1 plus 5 is going to give me 8. But in terms of solving for algebraic equations, we have to use a system, right? So let's say it had a larger figure, or it had a lot more equations. Let's say it was 3x plus 5 plus 10x plus 25x squared is equal to 8. Then how would we be able to determine x? Well, we need a system of solving it. So usually we use a system of BODMAS, right? Brackets of division, multiplication, addition, subtraction, right? So in this case, this is a more simple case where all we'd have to do, I'm going to take my pen tool here, 3x. If we were to subtract 5 from both sides, yeah, subtract 5 from both sides, our result, sorry about that 3, that 3 is a little suspect, but this here would cancel off and go to 0, so we'd be left with 3x, should probably use the text for this, 3x, well, 8 minus 3, that's 5, right? Sorry. Oh, made an error there. Thank you for pointing that out. This should be 5, right? This should be 5. No wonder the 3 was off. Right, so this is 3. So the next step in determining what x would be, we would have to divide by 3 on both sides, right? Do the opposite of what 3 is doing to x. It's being multiplied by x, so we have to divide on both sides, right? So if we were to put the whole thing, it'd be, right? Okay, that's a 3, okay, guys? And then x will be equal to 1, right? 3 over 3, that's a whole. So x is equal to 1. So much of what we're going to be doing involves questions like these that we will have to be tackling. So that's the solution of a linear equation with one variable, right? And I'll put some practice questions up so that you guys can follow and try some of them yourselves. Let's look at another example. Okay, I'm going to switch boards here. I'm going to switch boards. All right, let's look at another example. Let's say 5x minus 3 is equal to 2x plus 9. Okay, well now we don't have a simple numeral on the other side of the equation. We're comparing two different linear equations. Okay, so Michael, how do we work on that? Okay, so let's go down here. Now just a matter of grouping the like terms. So we have 5x. Let's subtract 2 from both sides. So minus 2x is equal to 9 plus 3. Right? We're adding 3 to both sides. I mean, you could do this in a number of steps, but just to save time here, I'm just going to write out the full expression. So 5x minus 2x, that'll give us 3x, equal to 9 plus 3, well, that's 12, right? So 3x is equal to 12. Well, what number multiplied by x would give us 12? Well, we know this intuitively to be what? That's correct. The answer is 4. So x will be equal to 12 divided by 3. So therefore x is equal to 4. Okay, let's look at one more example. What if x, let's use an example where there are brackets involved, yeah? So let's say 7x minus 2, open brackets 3 minus x. Oh, I'm sorry. So let's look at another question, okay? So let's look at one involving brackets. So 7x minus 2, open brackets, 3 minus x is equal to 12. Okay, so Michael, how do we solve this? Okay. Well, first we need to use our system, right? Our system says that brackets comes first. So we need to expand the brackets, right? And the distributive law, you can look it up, the distributive law, I'll just write it over here for you guys. Look it up. The distributive law states that anything, oh, I'm sorry, get that out of there. Distributive law states that anything immediately outside the bracket is multiplied by what is inside the bracket. So we can see here that what is immediately outside the bracket is 2, right? Negative 2. Get my pen tool here. Negative 2. Negative 2 is immediately outside the bracket. So we're going to multiply negative 2 by each component within the bracket, right? So we're going to multiply by 1 by negative 2 by 3 and negative 2 by negative x. So get my tool here. So if we were to expand this, this will be negative 2 by 3 gives me negative 6. Sorry, negative 6. And then negative 2 by negative x, well, negative by negative is positive, so we get positive 2x, okay? And that is equal to 12. Okay, so now we've broken it down into a simple format that we can solve easily, right? So let's group the terms. So 7x plus 2x would give me 9x. And I'm going to carry the 12 over. So this becomes a positive 6 because we're adding 6 to both sides to cancel the 6 on the left-hand side. Sorry. And that's positive 6. Yeah? So now we have 9x is equal to 18. Yeah? And well, we know what number multiplied by x will give me 18? 2. So x is equal to 18 divided by 9. X is equal to 2. Okay, so I think we've got the gist of it. One way that I wanted to show you is like, think of an equation like a seesaw, right? If we have, I'm going to try and draw a straight line as straight as I can. Let's say we have well, not so much a seesaw. I mean, this is going to be a strange seesaw, but let's say we have a seesaw, something like that, and then we have a weight here and a weight here. We want this weight to balance itself, right? We want this weight to balance itself. So in order for that to happen, this and these two items must be equal. If you know anything about what a scale works, how a scale works, right? So I'm just going to use the example that we had before, right? So I'm putting my text inside here. This is 3x plus 5. And here we have 8. So in order to balance, that x component must give me a value of 8, right? Let me just fix this here. So I'm put that inside here. Whatever x is must give us a, right? Because so this kind of tells us about the equal sign, right? This is how an equation works. And equality works in somewhat differently.